Hey guys, welcome back to the channel. I think this is build video number 6, maybe, in the build series. I don't know at this point. Anyways, we are kind of wrapping up all the final small details on this Hawk, all the really fun details. So stay tuned and we'll dive back into this beautiful, massive aircraft. All right guys, so last episode was primarily focused on the cockpit assembly and everything, which we got done. We got the most part of it done. We still have to wrap up all the fine details and all the detail work. So that's what we're going to be doing in this episode. We're going to be finishing up the light install and hopefully getting all the equipment install done. So lots to do in this episode. So let's dive into this plane. Don't forget to give the video one of these while you're thinking about it, and also hit that subscribe button down below. Let's get into it. All right, so kind of the first step I did here is go through and paint all of our pieces black. So our cockpit tub supports, the cross braces, did a bunch of touch-ups on the black parts of the cockpit, stuff like this. Intakes, you could see white there before, painted that all red. So just lots of little touch-up areas. Next thing I'm going to do here is last video when we were putting the canopy on, the only way we could get that rod through was through the hole here. Well, don't plan on taking this canopy off anytime soon, so I'm going to fill this little hole. I've put masking tape on the back. I'm going to fill it with High-Sol, and then we'll sand it off and then give it some touch-up in red. All right, guys, so canopy operation is complete. What I did here was take a piece of carbon, it's probably 1/8 carbon, and that screws into the main former. That joins the front and the mid part of the fuselage. So we've got the actuator bolted to the carbon, and then we've got the carbon bolted to the former. So it's a nice strong option for the actuator that's opening and closing the canopy. The reason I needed to get it out like this was to create a nice straight line as much as possible, and then ended up going with a ball joint here with a washer on it. Clevis would have been okay. The problem is any sort of side-to-side force, because this is a wide piece of G10 here, it's actually, you're not able to put a retainer on the clevis, and we would have had to have this linear actuator kind of pointing back towards the gear opening. So it's just a better scenario for the whole canopy to have it positioned like I did it. So it works. I've tried it. It's good. I'm going to be doing some adjustments to this. So once I get it adjusted, then I'll show you how it works. What I did was initially take a file, just put a little bit of a bevel here just to make sure that it doesn't impede the canopy closing. So I did that on each one. Then I took my Dremel bit and I opened this forward one up. Reason for that is this was catching, and if you think about it, you've got all your force opening it on the back. Yes, you've got this massive square piece of carbon tubing on both sides, but there's still, it's not an easy time for it to distribute the force from the back to the front. I mean, there's going to be twisting motion in all of that. So having this open a little bit doesn't affect anything because we have a lock, right? So just prevents this from catching. But it's operating great right now. We can make it a little bit better, but that looks really good. All right, guys, so last night I was thinking before I went to bed about this whole scenario here, and we've got a problem we've got to deal with. So think about this. We'll do it in the scenario of you're done at the end of the day. So you're done at the end of the day, you're taking your airplane apart, your cockpit's open, and you pull your pilots out and you pull your battery connections out, and how do you close your cockpit? Well, these linear actuators, you can overpower them. The higher ratio you go, so the more strong they are, the harder they are to overpower. In this case, these linear actuators are the ones from the F-14, the stock ones that we did not keep. So they're pretty high power linear actuators. So what does that mean? It means we need to be able to connect a battery to the outside of the aircraft So I'm going to tell you how we're going to solve this problem. It's super simple, but it's going to solve this whole canopy cockpit kind of issue. All right, pretty simple solution. What we need to do is have some sort of plug on the outside of the aircraft where we can plug a battery in, have the system power up, and be able to open up the cockpit. Because you don't want to be traveling and moving the plane around with the canopy open. It's just not a good idea. So what are we going to do? We're going to take one of these MR30 plugs, this guy right here, probably like that, I think, maybe, somehow. Anyways, we're going to add a plug on the board to be able to plug a battery in. So super simple and good option to solve this problem. So you get to the field, you want to assemble your plane, so you pull this hatch off, plug a battery in, and that powers up the system. On your jetty radio, you flick your on switch, the plane turns on, and then you can open up the canopy. Once that's done, you can unplug this battery, and then you can plug the batteries in where they belong. So simple little solution. Not entirely sure how we're going to get that set up yet, but we will figure out a good solution for it. All right, guys, so we got the plug all done here, and it's all wired into the central box. So this is just a plug to keep anything from contacting our pins. So it's just a safety plug. Used one that you had the back plate on, so it's got a nice grip on it, and filled that up with hot glue, so it's completely protected. So the idea is you get to the field, you pull your airplane out, you put it on the stand, you pull the plug out. You then take a 3-cell LiPo, because that's what we're using through the central box, and you plug it in, and now you've got power to the system to open up your cockpit and get access to your front where you plug your batteries in. Once you're done, take the battery off, take your plug, and pop your plug back in, and the system is safe, no shorts here, and now you're running off of batteries in the nose. I don't think I recorded this last night, but basically last evening was just spent organizing everything. So all I did was have the radio on and just go through all the channels. So mainly on the right-hand side here, so channel 10, 9, 11, 12, all the way down to 17, and just making sure we had those lines run to the appropriate location. Now some of those lines were the one coming to the Cortex for the programming port, and then the GSU as well too, which comes back to this area here. So all that stuff is done and run all underneath this tray. So this tray is pretty much ready to glue in place. We also got our random motion generator for our pilots' heads installed. That's right there on the board. And so yeah, all that stuff is done on the front board. These are all of our main servo wires. Those all need the ends crimped on. I think the things we're moving to next is going to be crimping these wires. We are going to be hooking up all the air system. Now we've got a bunch of air connections that need to happen back here and go to their appropriate locations on the board. The board is still loose. All the servo lines are loose enough so we could actually lift this board up nice and easy. And then the way these air lines are going to be run is they're going to be run underneath the rear board. So really good access in this plane to all the supplies. And so that's kind of the next progress, but let's also talk about the lighting setup that we're going to use, because that's also going to be one of the next things we do. So the remaining lights that we have to hook up or install are the light right up here, which is going to be, I think, our white blinker, I'm not sure, and then our nose light as well too we have to get installed. So let's talk about that nose light. So generally with Unilights, the easiest way to do it is to provide power by a 2-cell LiPo. Now we are only going to have 3 batteries in this aircraft, and that's just the way the owner runs his aircraft. Same batteries for every aircraft, almost every aircraft, and just keeps things nice and simple. So in the case of the Cortex 310, you can plug a 3-cell LiPo in, but you can run the system at 8 volts, 8.4 volts, 7.1 volts, whatever you want. So that poses a bit of a problem, because our controller would be getting power directly from the battery. Now, if we put a voltage regulator or a BEC, a BEC, between the battery and the controller, the BEC doesn't know when it gets turned off. So we've got a solution for that. Now the Unilights all come with resistors. Now these resistors are to be added if you're providing power with a 3-cell LiPo, 3-cell life battery. Now you can see here it's written on the label 2S and 3S. So this light here out of the package operates with a 2-cell LiPo. If you want to operate it with a 3-cell battery, you have to include the resistor in addition to the system. Now the resistor, all the lights already have one in there. The resistor doesn't care which line it goes on. It just needs to be added in the system. Doesn't matter where. You don't have to put it beside the other one, just somewhere in the wiring of the system. Now, looking at the nose light here, you'll see the package for it. Okay, this is the package for that nose light. 2S is there, but there is no 3S option. So you cannot run this on a 3-cell battery without having it cause issues. And I think it's even shown in the manual here as well too. So this is our product, this bottom one, only 8 volts. The other smaller ones are 8 and 12. So what are we going to do about that? We're going to basically install the resistors in line with all the other lights, which is super simple. And then what we're going to do is we're going to have our BEC, our BEC, between the plug for the spotlight for the nose and the actual light itself. So our BEC is going to be right here. And so what happens is when we provide power to the system, the Unilight controller turns on, provides power through this leg into the BEC, and the BEC controls the power through to the light. So fairly simple solution. It's the best solution I could come up with without adding a switch between the battery and the BEC, and without adding another battery to the system just for the lights, which is what we want to eliminate. So that's a little bit of a background on the lighting system and how I'm going to modify it to be as simple as possible and work great in this aircraft. So let's get back to the wiring, the air tubing, and installing those last 2 lights. All right, so I'll show you a bit of a tidbit here with the light system. So we've got a 3-cell LiPo plugged into the Unilight controller. The receiver and everything's on. The Unilight controller is plugged into a test receiver into the throttle channel. So if I throttle up, you can see everything turn on. Throttle down, you can see it turn off. So we've got the nose light plugged into number 8 here. Then it goes into a Cashflow Creations 10 amp BEC, and then it goes out to the nose light. So if we throttle all the way up, nose light turns on, all the way down, nose light turns off. Now the rest of the lights will all be run at 12 volts because they'll plug into the other outputs. Like the marker lights, the green and red, they'll go on number 1 and 2, and then our top and bottom beacons will go on one of the other flashing ones. And that is how we are going to set this light system up to run off of the 3-cell LiPo. All right, guys, so we added the light on the tail section here. Now there was one of the rivets or 2 of the rivets missing on this side, so that's pretty much the right location for it. Now the scale plane, it's actually located kind of right here, but in our case it would interfere with the elevators. So we went as close as possible, which is in that location right there. So it's a pretty small little LED, but we're just running the wires forward. Now what I've done is I haven't done anything to the rudder because I knew I was going to be taking it off and getting back to this point. So the rudder was never fastened in, and we never adjusted the play in the rudder. So one thing I like to do with these direct connection type systems, Skymaster commonly uses these on the rudders, is so the pocket that this sits in can sometimes be a little bit loose. So what I'll do is I'll take a piece of fiberglass tape, and you can, usually it only takes 1 wrap. So I've added 1 wrap around this thing, and that usually tightens it up just a great amount and gets rid of any sort of slop in that system. And then the other thing to check is the material that they used for the actual location where that rod goes into. Now in this case, I can see that they used carbon or fiberglass. There's 2 strips glued in there right in the center of your screen. So, but if this was, I mean, it shouldn't be balsa, but if it was balsa, you can drill that out and drip in some thin CA to help reinforce everything. But in this case, it's already a really strong material. So just something else to keep in mind and look for. And then now when we put this rudder back on, what we're looking for when it slides into that pin is a really tight fit. This is actually a nice rudder setup on this aircraft, because when you want to get it off, you just reach your hand in and you push up on this carbon rod at the front, and that allows enough wiggle room for this to come up, because it's a pretty tight fit, but it's nice to be able to get that off fairly easy. There we go. We just check our gap on the fuselage, and that looks good. And now we are nice and snug. There really wasn't a whole lot of play before, but there was enough that I could feel it. Now it's a lot more solid, so that's perfect. So now what we'll do is we'll tighten up the pinch bolts on the other side and get those nice and snug, and then our rudder is connected. All right, guys, jumping forward a little bit, but we got the wings on for the first time, and she looks awesome. Very, very big. So the reason we got the wings on is so the air system is all plugged in and everything, and we can test that air system before we put the rear cover on here. So the air system's all done. Tried to keep it fairly neat. This is all going to be covered up, obviously, so the point of all this is to keep it fairly neat but also serviceable. And we've got all the lines run forward here. The other tray is going to come to this area, so this is all going to be nice and hidden, but there's a shot of what it looks like. So pretty straightforward as well. Before I plugged all these guys in, I made sure I turned the air system on, and what I did was, you can see a little Sharpie marks on the valves. That was marking the valve in the gear down position. So green is doors open, blue is gear down. So anyways, that's it for tonight. We're going to call it a night, and we will continue this big, massive hawk tomorrow. The last thing I'm finishing off with here is running the turbine wire that plugs into our beast. So the main bus wire right there, and that's the last thing we have to run to the back here. So once that's done, we can start focusing on getting that other tray in. So last couple things we have to do is our belly light that is run from the bottom underside. The plug-in comes to here. That's as far as it would reach. So we have to put an extension on that one. Also add the resistor in there. And then we've got to, as a last step working forward here, we've got to add our top light, our top beacon, and run that wire forward as well too. Once that's done, that's it. That's the last thing. And we can button this guy up. So. All right, so I'm pretty sure we've got everything finally run. All of our cable bundles are nicely tied down, and I installed the light, and it is curing. I'm just going to peel that off carefully. Nice thing about using the Goop or E6000 on the lenses like this is they cure pretty quickly. So I put this on probably an hour or so ago, and it's already solid. So anyways, the light's done. Pretty straightforward, just Dremel a hole, fit it in, and I just used CA in this case to kind of spot weld it in place, and then filled it in around the cutout. So anyways, that is the white light, I believe. So that's all good. Front's all good. We do have our Model Aviation products order supposed to be here on Tuesday. Unfortunately, UPS crapped the bed. I don't use UPS pretty much ever because they are hands down the worst shipping company I've ever used, and they delivered it to the wrong location. So we don't have our Model Aviation products order. It should be here. If they don't find it, they're going to ship out another order, and hopefully it's here next week. So anyways, time to get that the rear tray installed. All right, guys, all the lights are off in the shop, and this is the camera never picks it up well, but this is the light. So the lenses turned out really nice. I'm glad I put that lens over top of the light. What happens is it really spreads that light out. I'm talking about the little lens from Unilite. Our top light there, really bright. That's synchronized with the beacon on the bottom. Nose light is super bright. That's really cool. Really nice setup on this hawk. And there's a shot of the tail, which is just cool. So that's beautiful. Turned out really well, better than I was expecting, and especially the red and green wingtip lights. All right, guys, so at this point in the build, things are a little bit slow. Just plugging away at little things here and there. I got my 3D printer guy, Joe, thank you, Joe, to make me some MR30 plug holders. I'm not planning on having these on the website, but these are just for my own builds. So what I use these for is they're a 3-pin connector for connecting the cockpits to. And that's just going to make it much more clean and simple. And we'll probably mount those guys down here in the board is what I'm thinking. So we've got everything kind of squared away. I have gone through and programmed the compressor through the radio. I've programmed the limits on the turbine and set up the remote on-off switch. So that's now done and we can switch that on from the receiver. So next thing we're doing is we've got to deal with the canopy sequencing and stuff. So that involves the linear actuator and the servo lock right here. So what I'm doing is I'm just setting up some demo servos plugged into those channels so we can play around with that stuff in the radio and get our sequence and everything figured out and make sure that, that it all works. All right, guys, so just going through the fine tuning here for the canopy system. So what I've done is I've put two long leads on and hooked up 2 random servos here. So this is the lock servo and this is the canopy servo. So we don't want to add in another sequencer to make it complicated. So what we're going to do is we're going to do all this through the Jetty system. And what we want to do is we can't just use the servo slow function. Reason we can't do that is because when you slow down the servo, it moves slower through the whole range of motion. And we need this lock servo to initially unlock before the linear actuator starts moving, and then we need the linear actuator to move and this servo to not move until that thing is closed. So let's take a look at the Jetty system and I'll show you how we do this. So initially we had, going to model here, function assignments. So we've created 2 functions. We've created a canopy lock function, okay, number 13 there, and a canopy open function. Now initially, the control was my SN switch, which is on the back of the radio here. It's just a 2-position toggle switch on the back of the radio. So that's how I set it up to get everything programmed and limits and all that kind of stuff. So that was the initial step. Ignore L1 and L2 and L3. And then what we did is we went into advanced properties, logic switches, and we created L1 or L2 and L3. Now L1, what that is when you put the gear up, it actuates the brakes for just a fraction of a second. So anyways, that's what that L1 is for. So what we did is we went into canopy lock. Okay, we created this one as canopy lock, enabled it. Our switch is SN, and we changed our conditions here. So I need Trusty's help to point this out to you. So when you first open these guys up, this little line here is this squiggly line, which is like servo slow. So it initiates right away and then slowly happens. Well, you can change that line to be the straight up and down line, which is the actuate line, if you want to call it that. So our canopy lock waits 4 seconds before it locks, is in theory what we want to do here. So we created this, and then we also created another one called canopy, and this is for when the canopy actually opens. So we did exactly the same thing here, but we wanted to create a delay of 1 second before that canopy opens. So again, we have to do the straight up and down line, added 1 second. Initially we did it as 2. We have to play with that still. So those are created. And then we go back into model, function assignment, go back into this, and you go into the input control, okay? You clear this, then you hit the plus button, and when you hit the plus button, all of your different options come up. And all those options are logical switches and all that kind of stuff. So you've got a myriad of options that, that make that work. So what we'll do now is I'll actuate the switch. So right now it's in the closed position. So the lock unlocks and the canopy opens. Now we'll do the opposite. So you'll see the right-hand servo close. And 4 seconds from the first one moving, the lock locks. We'll do that again for the open. So you'll see the unlock servo move real quick. 1 second later, the canopy will start opening. Perfect. So what we can do now is we can get this hooked up in the plane and we can start playing around with the timing of everything for the actual servo and linear actuator in the plane. All right, guys, and we got everything set up working exactly as we want it to work. So I will flick function SN and we'll see what happens. Canopy closes, lock locks, and lock's going to unlock, canopy opens. Yeah, that's awesome. All right, guys, and that is everything for this episode. I kind of figured we would get everything wrapped up in one episode, but there's a lot of detail work that we needed to do and still need to do on this aircraft. The two huge things we accomplished in this video was essentially getting the whole trays and everything wired and the cockpits installed. Now there's still lots of steps to do. I'll tell you a little bit about that. So we've got to finish installing the pilot's turning heads and the mounts and the plugins and all that stuff. So that's one of the things we still need to do up front here. We need to do all the programming as well too. That's kind of a big one. And just the last final checkovers. We are still waiting on that smoke UAT, so we will install that when we get it. And we've got to do an engine run as well too. That's always fun and exciting, especially with the 300 with the Beast. That is absolutely awesome. Got to do our CG, our center of gravity, and yeah, so still lots of little things to do. I find this part of the build always takes a ton of time. The programming, I remember the F-18 we built about a year ago for John down in the US. I mean, I had that thing in programming mode for probably 8 to 12 hours. I think it was quite a process. So anyways, guys, that's it for this video. Thanks for watching. We will wrap this guy up in the next video, so really looking forward to that. Thanks for watching. Don't forget to give the video one of these if you liked it. If you are not a subscriber, hit that subscribe button down below, and we'll see you guys in the next video. Thanks for supporting the channel. Take care.